Welcome to a short video on how to conduct a between subjects one-way ANOVA. You'll see I've set the data file up correctly, and so that means we've got one variable which is their condition or grouping variable, in this case IV. So this is your independent variable. Normally you'd have your variable name there which would identify it, and a second variable which is your DV, in this case some form of outcome or dependent variable, which is at least interval data. You'll notice that there is, in this case, more than two conditions, and so as a consequence we're going to conduct a one-way ANOVA on it. You'll also notice that it's between subjects because each participant only takes part in one condition. So we have 30 participants, 10 in each condition, and some form of dependent variable or outcome variable. So to analyse the data, we click on Analyse General Linear Model Univariate. This brings us this dialog box. So it's asking us which are the fixed factors. In this case this means the independent variable or the grouping variable. So this is our independent variable. You see it's set up as a nominal variable with groups. And what is a dependent variable? Well, we've called ours dependent variable, so it's quite straightforward. So obviously this may be named whatever your outcome or dependent variable is. We're going to set it up so we have some options. So in this case I want to display the means for each of those groups. So we want to see whether what the mean scores for each of those groups are. So I'm going to do some descriptive statistics and some estimates of effect size. You can also compare main effects from this. And we're going to put in a plot. Now we've only got one factor, so I'm just going to keep it as the horizontal axis. So this will just give us a little plot to help us understand what's going on in the data. This wouldn't be the main graph. I'd probably do a bar graph for this with error bars. So it's ready to go. So we click on OK, and then we have the output here. What we'll notice is the first table just tells us that we have three conditions. These are the labels of them, and these are the number of participants. It's given us some descriptive statistics, the mean scores, the standard deviations for each of those groups, and the overall mean. So in a one-way ANOVA, you know that the overall mean, these groups are being also compared to the overall mean to see whether these groups really vary in comparison to a null hypothesis which assumes that there is no difference between those groups. Here is our main table for the between subjects ANOVA, and what we are looking for here is our key factor. So this is this variable here, the IV. So these first two rows aren't necessary, so we can just edit those out to make this table more straightforward. We also don't need this total row here. So what you'll see here is it shows that there is a significant difference between those three groups. So there's a difference somewhere in the dependent variable dependent on the group or condition that you are in. And these are the degrees of freedom, 2 and 27, that you'd report in your ANOVA, and the F value that you'd report in your ANOVA, and the significance, and in this case we've got a partial eta squared effect size estimate. Asked it to produce some descriptives. Well, these are similar to what we have above, but what these have now got is our confidence interval, so we could use these to construct an error bar, or we could get SPSS to construct it for us. But what it's worth noting really is it looks like here, so this is the estimate of where we think the population mean will be. So this is between 2 and 4 for this group, between 2 and 4 for this group, so they seem very similar, but between 4 and 6 or 7 for this group, so this does appear to be the one that seems to be different. So if we look at our chart here, our figure, it looks like condition 1 and 2 are similar, with condition 3 being different. So we could run the analysis again and run some post hoc tests. So in this case we could run post hocs because it says there is a significant difference, but with a one-way ANOVA we don't know where those post hocs are. So in this case we'll just run a Tukey post hoc test just to see if our assumptions are correct. Now given those confidence intervals, I think we probably are safe to assume that. So it runs the same analysis, but let's go down to the post hocs. Now this compares condition 1 with condition 2, and that says there's no difference. It compares condition 1 with condition 3, and it says there is a difference between condition 1 and condition 3. So there is a difference between these 2 points, or between these two values. And there is a difference between condition 2 and condition 3, or these two values, or these 2 points. So we've run the one-way ANOVA. It suggests there is a significant difference between those groups or conditions, and the post hoc test, comparing where that difference lies, suggests the difference is between with condition 3, between condition 1 and condition 3 and condition 2 and condition 3, and you'll notice there's no difference in condition 1 and condition 2. And that's how you'd run a between subjects one-way analysis of variance.